decomposition, or the grouping method. Whew. It is more time consuming than the method we've used already. So that's why I'm teaching it last. And if you rarely use it or never use it, that's okay. If you're really comfortable with just getting the answer, but sometimes this is nice. So here's the method, and this method is really to help us with step 1 and step 2 that are new. Step 1 is how do we break up that middle term, which was the minus 13x, to get the minus 15 and the 2. How did we know those were the right numbers? And then step 2 actually wasn't too hard. Step 2 is look at your first two, factor out what's common. Then look at your last two, factor out what's common. And something in common appears, which you can factor that out again. So here are all the words describing how we're going to find it. First, write down the product of the first and last term and write down the middle term. So I'm going to go back to our example here. What is the product of my first and last term? 3 times negative 10. My product would be negative 30. Oh, you don't include the variable? Nope. Just the coefficient, the number, and the number. And so we would write product of my first and last one is negative 30. And you write down your middle term. And with your middle term, write down sum. And you ask yourself, can I find two numbers whose product is negative 30, but they add to negative 13? Three and 10, but if I used negative 3 and positive 10, that makes negative 30. It doesn't make negative 13. Oh, so 15 and 2. Oh, I erased my big eraser. Product was negative 30. Negative 15 and 2, do they work? So we multiply our outside numbers, and that's a product that we're looking for. We write down our middle number, that's a sum that we're looking for. According to step 1, that's why the P is there for product and S is there for sum. We now found the two numbers whose product is the one number and sum is the other number. Rewrite your middle term with those two numbers. We found minus 15 and 2. Those are the two numbers that we wrote down. That's how you find those two numbers. Whoa! That's why I said this gives you shivers a little bit. It's so neat how it works. Okay? And then you now have 4 terms. Factor a common factor out of the first pair and a common factor out of the second pair. So this was, in our thing over there, that was step 1. All of this was, that was step 2. All of that was step 1 in what we did here.
Why didn't we do that from the start?
Because it's longer.
But it just gives you a perfect method to find it so easily.
Yes, but I think I want you to be able to factor them directly because it will be faster. And it involves more mental math, which is good for your brain. And then once you have factored out the common pair, you should get a common factor, which you can factor out again. So we're going to use the grouping method. But before we do the grouping method, I'll give you 30 seconds to see if you can find the answer using the old method. Just writing it out and figuring it out. Okay, whether you found it or not, I'm going to get you to stop. If I multiply my first and last terms together, I'm looking for a product of negative 90. And my middle term, the coefficient is 1. Can you tell me two numbers whose product is negative 90 and whose sum is 1? 9 and 10. Which one has to be positive? Which one has to be negative? 10 is positive, 9 is negative. Can you see that if you multiply those, you'll get negative 90. If you add them, you get 1. And so now we rewrite the plus x in the middle with 10 and 9. I'll do it in a different color so we can really see it. Plus 10x minus 9x minus 15. Can you see that what I wrote in green is equal to the plus x that was there before? It will work for any trinomial. We're going to see positives and negatives in certain cases. This is an example where I think this method is faster than... Did you try to do it in your head? How many people got it? Couple? Okay, that's great. But this one was a hard one with mental math. Okay? It's hard partially because what makes 6? 2 and 3 or 6 and 1. What makes 15? 5 and 3 or 15 and 1. So when there's a lot of options, if you are trying the other method and you choose the wrong option first, it may take a long time because you have to try everything with that option only to find out, oh, that was the wrong option. I have to switch to the other one. So in this case, this method works out really nice. We've split it up. Now we have 4 terms. In our first 2 terms, what's common? 2x. Leaving me with 3x plus 5. What's in common in the next ones? Okay? There's the 3 in common or a negative 3. And so this is where sometimes we have an issue. Should I take out the 3 or should I take out a negative 3? In this case, we want to get another 3x plus 5. So I'm going to take out a negative 3 because that will give me 3x plus 5 again. And now in these 2 terms, we have a common factor of 3x plus 5. When you are done the grouping method, just like when you're done the regular factoring method, you should check, do my first ones match up with my first number? Yes. Do my last ones, negative 3 and negative 5, do they match up with negative 15? Yes. Do my outside numbers and inside numbers make plus 1? Negative 9 plus 10, yes. Plus 1. You're liking this method? A lot. You're liking it a lot. Okay, good. "30 seconds on your own to try and do it directly." All right. Whether you got it or not, now let's look at the grouping method. If I multiply my first and my last numbers, 4 times 9 means I'm looking for a product of 36. My middle number is negative 15. 2 numbers who multiply to 36 that give you negative 15. When doing this, you're always looking at the 36 first, because there's only so many things that multiply to 36. 1 and 36, 2 and 18, 3 and 12, 6 and 6, right? 4 and 9. There's only so many things that multiply to 36. You never start with the sum because there's an infinite amount of things that add to 15 or negative 15. Ooh, is it 1,000 and negative 1015? No. So you start with your product. So now thinking about your product, two numbers that multiply to 36, do any of them add to negative 15? Negative 12 and negative 3. They would both have to be negative to get the positive 36. And then a negative 12 plus a negative 3 makes negative 15. So now I can rewrite the minus 15 as minus 12x minus 3x. So I rewrote that middle number, the negative 15, as minus 12 and minus 3. Yes? It doesn't matter the order. So this is a great question, and I'm going to rewrite it on this side saying, what happens if I did the minus 3 first and then the minus 12? Doesn't matter the order. Well, we're going to see what happens if the order is mixed up. Okay? Here, if I factor out what's common in my first two, a 4x, leaving me with x minus 3. What would I have to factor out of my second one to get an x minus 3? A negative 3. X minus 3. Excellent. And now the x minus 3 is in common, so let's finish this side. What would I be left with in my first term? A 4x minus 3. If you had written it the other way, now when I look at my first two terms, what's in common? Just an x. And what am I left with? 4x minus 3. And what's in common in the next ones? So that I get a 4x, again, I'd have to take out a negative 3. 4x minus 3. Now what's in common? The 4x minus 3 times x minus 3. You love this method. It's beautiful. Okay? Now, when you get to the easier questions, like this one, try to do this one directly. Because it's easy. You don't have to write the star. Okay? The star is there because it's easy, and actually I would never want you to use grouping on this one. I would want you to do it directly. But if we did do grouping, what's our product? The first number's a 1 times a 36. It's a 36. What's our sum? Negative 13. And what are our two numbers? Negative 9 and negative 4. So we would rewrite the 13 with minus 9x minus 4x plus 36. That's the minus 13. What's in common in the first ones? X, leaving with x minus 9. What's in common in the next ones? So that I get an x again, I'd have to take out a minus 4, x minus 9. But for this one, I never want you to do this method, because you should, and it's so much faster and so much less to write, just write out the answer. Because if you think of undoing FOIL, right, the x in the x is always my x squared. The last numbers have to give me 36, and my outside and inside have to add. And when you have a situation like this one as well, I never want you to use the grouping method for one like this. When are the ones that I say I don't want you to use the grouping method? They're the ones where your first number, see that that's a 2x squared? If that's my first number, I'm going to underline it in green, there is only one option for my first numbers. It has to be 2x and x.
So when there's only one possible option for the first term, that's when you use the...
Just go directly, because it's not that hard mental math. Now, my last numbers, either 5 and a 1 or 1 and 5. Can you do the mental math quickly enough to figure out that my last one should be a 5 here and a 1 there? Can you see that your outside is 10, your inside is 1, that makes 11. We're done. Okay? But grouping does work for this one, right? If you do the product of the first and last number, it's 10. If our middle number is 11. What are two numbers that multiply to 10 that add to 11? 10 and 1, or 1 and 10, doesn't matter. I'm going to do 10 and 1, because you said that first. And so I write this out, and I want to talk about this one with the grouping method, because this is one that sometimes people make mistakes. What's common in the first two? 2x. So far, everything is good. Leaves me with x plus 5. But there's nothing common in the next ones. So what do we do?
Just leave it as is.
We could leave it as is, or we could take out a 1. Because a 1 doesn't change anything. But then I have the common factor. You do leave it as it is, but sometimes if you leave it as it is, people don't see that they have to write plus 1 here.
So you just basically pull out of one out of thin air?
Well, 1 times everything is still 1.
Oh, yeah, kind of. You can multiply it by 1 like a million times.
That's right. So I find because of that little issue, the grouping method causes people issues at that point in this one. And so if you can factor it directly, factor it directly. Now we're going to take one from yesterday where I'm not sure if the grouping method is necessarily that much better. Yes, this would be typically one that you would say, ooh, 42 has lots of options. I should use the grouping method. Okay? So what's our product? Oy, 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 oy. We're looking for two numbers where the product is negative. Oh, I should write the negative in there. Our product, negative 2,646, and the sum is 5. Oh. So what would you do? A factor tree? Sure. So let's look. I'll do that on a separate page. 2646 is 2 times 1323. 1323 divides by 3 because it adds up to a multiple. So it's 3 times 441. 441 divides by 3. 3 times 147. 147 divides by 3. And 49 is 7 and 7. So the prime factorization of 2646 is 2 times 3 times 3 times 3 times 7 times 7. And you can use this to start writing out all the possibilities. Okay, obviously, that's one possibility. 2 times 1323 is another possibility. We have 3 times, could take the 3, and then what am I left with? 2 times 3 times 3 times 7 times 7. 882. What's the next smallest number that I could combine in here to get? Can you see that I can't make, with those factors, I can't make a 4? I don't have a 5, but I could use 2 times 3 is 6. And then I'd be left with 3 times 3 times 7, which is 441. What's the next number? 9. And then I'd be left with 2 times 3 times 7 times 7, 294. Have we got any that are close to having a difference of 5 yet? No, but we'll have to just keep going. So I don't know if the grouping method is that much faster in this case. What's the next number that you can make after 9? 12. 3 times, no, you can't make 12. How would you make 12?
2 times 3 times 2.
I've only got 1, 2 though. 2 times 3 times 3 is 18 is my next number, yes. Oh, 14 is my next number. Thank you. Thank you for noticing 14. 14 is the next number because you can put the 2 and the 7 together, leaving you with 189. What's the next one? 18. $147. I feel like we're getting closer. What's the next number after 18? 21? $126. What's after 21? And the crazy thing is if you miss one, you might miss the important one. What? Is 27 the next number? 3 times 3 times 3? I think so. How long is this question taking us? A long time. We still haven't found the two numbers that have a difference of 5 in them.
So
What's the next one?
the distance between the numbers keeps getting smaller.
It does. So we're getting closer, aren't we?
So can't you like kind of
Skip some?
skip like the first 5 numbers because you know there's going to be like hundreds.
Yes, you could skip the first couple. So which number do you want to try after this? 42? Still not a difference of 5? 49? Oh, look at that. And so 49 times 54, so now we go back to here and say it's going to be 54 and negative 49. All that work to find those two numbers. By this time, some of you might have said, the direct way, I would have figured it out already.
Well, it's like you have to go, that's only if you assume that you guess the first, like the numbers right. If you don't.
Right, so it's a give and take. If you get the first two numbers right, it could go very fast. If you don't get the first two numbers right, you could spend so long on the other method as well. So what we're saying is at this point, the factoring gets difficult and time-consuming no matter which method you have. And like those numbers I showed you earlier that were really big, it's the same kind of problem. No matter what method you have, it takes a long time. Yes?
Can you also use a factor trick? Like take the factors and multiply them into the
Like in here?
and like just guesstimate.
Yeah, you could use this because this is going to be 2 times 3, 6 times 18 times 47, and that's what 147, what came up, right?
Yeah. No, I mean like there, the numbers are literally in order.
Yes.
2 times 3 times 3 times 3 times 7 times 7 is 49.
Right, you could use the 49 here, and this is this 54, and you could put things together. So yes, I did it systematically and wrote them all out, which made it extra time consuming. You're right, you could skip some, like you said before. Yes?
So if we had to skip a question on our test,
Yes?
would we have to
Would you have to write them all down? No, you just have to somehow come up with the ones that are 5 apart.
You just want us to show that we actually got the number somehow? Like, we actually ended up with the number, not just pulled out our thin air?
Well, you could, if you just wrote down 49 times 54, I would know you did something on scrap paper, right? And so now we could rewrite that middle number as plus 54x minus 49x minus 63, and now life is easy, right? What's in common? You have to know your times table. 6x, leaving me with 7x plus 9. What's in common here? Negative 7, leaving me with 7x plus 9. 7x plus 9, 6x minus 7. Whew. Only took a long time, right? Factoring can take some time. You can save significant amount of time off your factoring by improving your mental math skills. One of the best ways to improve your mental math skills is to practice factoring. So we are going to take the last time in class to work on this.